Hey everyone, how are you? I know everyone's working from home, and I've actually had a few people ask me how to do certain things, and it's really hard to direct somebody to so many videos to go watch and learn. So today I'm going to just do it in person. We'll see how much of the camera I do. So forget about tangents and secants and derivatives and whatever else for right now. Let's just go over the most basic concept. You have a color, black, and a color, white. We can say that these are opposites, right? We can say that maybe this is a 0 and this is a 1, right? This is false, this is true. So we have this theme of opposites, right? And to continue with this, let's take a look at the operators. So we have addition and subtraction, multiplication and division, however you want to denote those two. And then you've got this thing and this thing. So as you can see, the derivative is actually the opposite or the inverse of the integral, and the integral is actually known as the antiderivative. And for our cases, this is going to be generally true. So while it may have seemed a little silly to go over what these operations are and colors and true and false, 0 and 1, the point is that on this side, there is something on this side of the line are opposite from things on these side of the line. That should tell you some sort of relationship between here. And the relationship is that they are opposite. And so what do we say the equal sign means? This always blew my mind. When we say something equals something, it means that I performed a mathematical step that was equal to something else. If I want to take the derivative of x squared, then that means I would have to use the power rule, right? And if I took the second derivative, so this is kind of interesting. This equal sign means that I performed an operation correctly. And literally, the opposite of equals is does not equals. That's wrong. So this tells us that we performed an incorrect mathematical operation. And the way that we know this in calculus is partly because of algebra. But before we get there, we can use the basic integration and differentiation sheets to verify that our answer is correct. And in fact, it even contains a formula. They all contain a formula, for the most part, of how to do the calculus. All we need to do is manipulate the function, this thing, to look a certain way. In this case, it's u to the n. So the operation is u to the n equals n to the un minus 1. We have f prime of x squared equals 2x. And I can even do this. 2 minus 1. And that's how you do it. I'll show you the sheet. And so this one's going to be number 6. And this is one of the rules that's on here. I'm always on the lookout to make my work better, check my work, or I try to, and I was just going over and I saw that this was an error. Sorry about that. I meant to put that this is not equal to. I was trying to prove a point about the equal sign. We're going to let x squared equal u. And on the other side, what we're going to say is that to get f prime of u, we need to do this thing that will equal n u n minus 1. And we can say that 2, such that 2 equals n. Okay? So, to put it together, now we have rights to calculus. Now I just matched up this form, which equals x squared, to the left-hand side, which now says, hey, you can perform this step here, and the equal sign will be true. And so I do that. I say, okay, 2 minus 1, that's fine. We can do that. I'm going to put 2 in the front since we said that 2 is equal to n. And what's u? Oh, x. And so this is how you do it. And to complete this, we can just keep moving left to right. So we can just keep simplifying. 2x, 2 minus 1 is 1. And then we can say 2x. There you go. You just did your first derivative using the simple power rule. So now that we know that we can use this form over here, I think the question was, how do we do something like this? And it's pretty interesting because we know that there's a form that says we should be able to do division of some sort. And do we see anything that we know that could be a divisor? Yeah, we do. We see something like this. Can we use this? No, because we don't have a logarithm. This is kind of, oh, well, we might be able to use this guy. But this is like pretty clumsy. I mean, we got to use this big thing just to solve this? I don't think so. And so there's actually something that we can do that's even easier. And what we're going to do, and I recommend that everybody do this, right? You have the function on the left-hand side, and you say division. So what do? Algebraic manipulation. Because remember, this left-hand side has to equal the right-hand side. And if I can perform algebra, then I'm going to be in good shape. I actually might even have something easier than that huge equation. And so I'm going to say that y, remember what I can do with this? In a rational or a fraction, I can actually do this. And so that's pretty cool. You just kind of put a negative in front of it and then move it up. Now we know that we can do dy dx. This is the operation for doing a derivative. So just like we know x plus 1 or 2 minus 1. This is saying let's take the derivative. And what we're going to do, remember, is we're going to bring this to the front and then subtract by 1. And the derivative of this is going to be multiplied by that. But don't worry, because this is already 1. So we're just going to leave that as it is right now. So to rewrite this, I'm going to say negative 2x is negative 3. This is a good answer. I mean, we got the derivative, right? Well, here's the thing, right? This is actually now kind of improper. And they didn't give you something like this to begin with, did they? So it's only right to kind of put it back into this form. So how did I get it here in the first place? I just moved it up. So how do you think that I get it back down? I literally just take this and I move it back down to the bottom. And I do that by doing this. I just keep the negative 2. I can keep it out front. And I can say, I want to write this as a positive 3, and I'm going to put it over 1, because that's what we did to get it here. So we can now simplify this and just say that this is negative 2, which is maybe the best way to go, negative 2 over x cubed. We just did this basically with algebra. We basically just used algebra as a proof, as a running proof down the right-hand side to show calculus. To demonstrate calculus. And so that's pretty cool. Now, is it so hard to believe that most mistakes are actually made in algebra? As you can see, we just took the left-hand side and we matched it to a form that we could use, which is this form. This is x to the negative second, and this is u to the n. Now we have rights to perform calculus after performing this algebraic maneuver. To do this, we use the left-hand side to say, do this right-hand side. And then we just cleaned it up with algebra. And look, the left-hand side is equal to the right-hand side. This is the basics of calculus, is just the algebraic manipulation. Get familiar with it. So I think one of the other questions that was asked was, how do I do a radical? How do I take the derivative of a radical? And so you've got this, and you're saying to yourself, I don't know any differentiation rules that match this. But what you do know how to do is algebraic manipulation. Now, this equals u to the n, right? And so now we can do this. And now I need to subtract 1, so this becomes negative 1/2. And now we just clean it up with algebra. 1 over 2 x 1/2. And I'm just showing you all the steps, just in case you get lost somewhere. There you go. And that's how you do it. And this thing over here on the right, this one gave me the rights to now perform. Putting it in this form gave me the rights to now perform calculus. And then the algebra was really the rest of it. I used algebra as a proof to go from this form to this form. And that's the whole idea about using these differentiation and integration formulas. Now what we're going to do is we're just going to do maybe 2 integrals. And they're going to be pretty simple and straightforward, indefinite integrals. So it's going to be integral of 3x times 2x squared minus 2 raised to the power of 3 dx. So I would recommend that you guys write the problem in red so you know where you came from. Like I said, I like to kind of draw a running column down the right-hand side. And so now I'm going to just kind of use the rules. All I'm going to do is I'm going to just kind of rewrite this first, because I want to put the most complicated function in the front. And the reason for that is because we do the integral of u du. So I'm going to let u equal what? The inside of this function, 2x squared minus 2. And the derivative of that is pretty easy. It's just going to be 4x dx. Now, can I get 4x dx somewhere in this function? If I want to do the integral of this, I need the derivative back here, because we said that that's what du equals, right? So if I were to rewrite this, and the answer is yes, I can. And so to rewrite this, I'm going to pull the 3 out, 2x squared minus 2 power of 3 x dx, and I want to get 4x in here. And the reason I can pull the 3 out is because it's a constant. And so that's fine. It's not going to affect us. And the answer is, yeah, I can absolutely get a 4 in there, but I have to pay the penalty by multiplying it by 1/4. I need to do the inverse of that on the outside to balance the equation. Remember, the left-hand side has to be equal to the right-hand side. And then I just add it in. I'm not doing anything to this function. This is fine. We've already established that u is equal to this inside function. So that's no big deal. And I'm just adding the 4x dx, and I paid the penalty by multiplying by the 1/4 on the outside. Let's finish it up. Let's rewrite it so we can follow what's going on. We know that this is equal to u. So why not just write it like this? right? Now don't I have rights to calculus? Now isn't this in a form that says 3/4 u to the n du? And if I look on the right side, this integration formula, that's exactly what we're doing, where n cannot equal -1. And we can go over that later. So n here is equal to 3. U equals 2x squared minus 2, n equals 3. Now let's just integrate it. So using this rule on the right-hand side, I can say that I'm going to just do 3/4 times, I have to raise it to the power, u to the 4th power, and then I have to put it over the same number 4, n plus 1. And then I have to put the c. This just cleans up nicely to 3u to the 4th over 16 plus c. Now, what I have to do is I have to substitute u back for what we started with, which is this, 2x squared minus 2. And so let me do that. And that's the answer. And you can see that logically, this makes absolute sense. If we step through this step by step and we say, okay, I'm going to do a substitution for u, that's what we did. And we proved through algebra that these steps were valid. And the calculus took one step. Here's the calculus, by the way. This to here is the calculus. It's one step. It takes 1 second. The rest of it is just setting it up to be in a form like this. We matched this form, so therefore we have the rights to perform calculus. And we did it with 1 step. That's it. Okay, let's try one that's a little more challenging but doesn't require any special kind of rules or trigonometric identities or substitutions or anything like that. This is just going to be strictly something similar but a little bit more difficult. And you might say, yeah, this looks easy, we can do this one. But the point is that we need to remember that doing this is very important. Drawing this box for ourselves to say, this is what we can use. This is what each thing is equal to. U is equal to this. Du is equal to this. And so let's try that. I'm going to draw a box. First of all, I'm going to draw a box. And I'm going to label everything. So you don't include what's inside. And so the derivative of this is what? Just 2dx. Let's rewrite this. Maybe it's a little bit easier to see if you have something like this. That's how I know not to take it. I just take what's inside the parentheses or inside the radical, and I do that. Okay, and actually we can keep going with this, because I don't really want to do a division rule. In fact, I can't because it doesn't even match. What I'd like to do instead is manipulate this. We do know the simple power rule. So I'm going to bring this up and make this a -1/2 dx. Let's do this so you can see it a little bit easier. And the problem is that I forgot the x. I actually can't do this. And the reason why is because I can never get x by itself. I only have a 2. I can't give myself a variable. I can only give myself a constant. Like in this equation, I gave myself a 4, and that's totally fine because I can pay the penalty by multiplying by its reciprocal on the outside. That's totally fine. So when I do this, I have 4 over 4 cancels out. Canceling this thing out like this is impossible. I can't give myself an x on the outside. That's not legal math. I can't give myself a variable on the outside. the only solution is to, well, one of the only solutions, what we're going to do is called, and I'd recommend that you kind of make notes on the outside. So can't get x, right? I can't get x. So you can kind of list everything, but we're going to do by substitution. And I'll even put by u-substitution. Okay, so now I'm going to solve for these other variables because I need to substitute dx for dx. And I need to solve x for x. Obviously, we have to solve for them now. And the way that we do that is just algebraically. Again, if it's not obvious to you that algebra is pretty important, it absolutely is. And just some critical thinking. Okay, how do I get this? If I need this, how do I get it? And we do it through algebra. Now I need to solve for x, and that's going to be u minus 3 over 2. In fact, you can put everything on the left-hand side, and I would recommend probably doing that, and I'll show you why. Because now all of your variables are on one side. I have u, du, I have dx, and I have x. I've solved for every single variable in here that I will need in the equation. Okay, let's just substitute. Now I'm going to substitute x into here, and that is going to be done using this equation because this is a little bit easier to work with. This you're going to be plugging things in. It's going to get really messy really fast. I mean, you can, but I'd prefer not to deal with this right away. So using this, we're just going to say this is equal to the integral. X is equal to, what did we say x was equal to? U minus 3 over 2, and just start writing it. Here we go. Over u to the 1/2, because we let u equal 2x plus 3, and we know that dx is equal to du over 2. And so this thing right here, this just shows you that this is the main point of division. All right, so now we can clean this up before we even try to perform calculus. This looks really ugly. Let's take this 1/2 from the du out. In fact, there's a couple different ways you can do this, and I'll show you both ways. And we have u minus 3. Now that I'm looking at it, it actually is kind of cool that you can do this two ways. And 1 over u to the 1/2. And obviously, we cannot forget about du, because all I did was pull out the 1/2. And actually, this can be done two different ways now, which is kind of cool. And the first way that I'm going to show you is distribution. And the second way that we're going to be able to do this is short division. There's probably other ways, but these are the two that I just saw right off the top of my head. So the first way is I'm going to pull this 1/2 out again. And on this side, I'm going to pull the same thing out. But instead of kind of this distribution, I'm going to just rewrite it. And I'll show you what that looks like. And so you could combine these, or you can just leave them. Either way is fine and legal. Some people might prefer to distribute, and some people might prefer to split these right away. And I'll show you what I mean by that. 1/2, 1/2, and we're going to distribute in u. So this is going to be u to the 1/2 3u to the 1/2. So far. And that's literally all we did. That's probably good. That's literally all we did. Now I can do something with this because I have these power rules. I put this now into a form that we recognize, u to the n du, for both of these. And we'll come back to that. But now just know that in your head, if you can get it here, you're pretty much home free. I mean, this is basically all you need. You're pretty much solved at this point. So that's pretty important. Put this on the side so that we can keep that in the back of our mind. And this one It's going to take a little finesse, but we're going to get there. I'm going to just split these. So I can only split fractions if there's addition and multiplication. 2 minus 3 over u to the 1/2. That's not. I'm going to do u over u to the 1/2 minus 3 over u to the 1/2 du. To be the same thing in the next step. So let's start combining these fractions now. I'm going to split these now. So if there's addition and multiplication, I can absolutely, and when I split them, I got to keep this constant to both of these. So when I split this, I have to remember to put du on the inside, and I have to remember to distribute this. Also, pull the 3 out. You don't have to. And you can also rewrite it like this if you wanted. That's fine. They're both the same. It's just that you're distributing this 1/4 through both of them. And you would need to do that because you pulled the 1/4 out of both of them. So now you need to make sure that the equation is balanced and give it back. I'm not going to do this one again for now. I'm just going to leave it out so we can concentrate on the calculus and the steps to get there. There it is. And we have two things that equal each other. Now, I'm going to just do one equation. And by the definition of the equal sign, 1/4. Now we're going to perform calculus. And it's actually pretty easy because now we know that these are both power rules. This matches, so I can prove that now we have u to the n du minus 3 u to the n du. Now we're ready for calculus. And the way that we do this is to just follow the rules. So I'm going to do step by step so you guys can see. Over 3/2. And this is, remember, this isn't multiplication. That's just to let you know you need to do something with me. You need to clean this up. Plus c. Don't forget the constant. And now I'm just going to clean this up. I'm going to keep writing this on the outside till I'm ready for it. I'm going to just perform manipulation, and to get rid of this in the denominator, we're just going to multiply by the reciprocal. It's the same thing as division. Remember, the inverse operation. And I have u to the on top minus plus c. And so now I can start doing something with this. I can substitute the original equation back in for u, which we said 2x plus 3. That's definitely better. So to keep going, distribute 1/4 times 6. So it's going to be 6/4 to the 1/2 plus c. And now I can start to rewrite this. So it's only polite, like I said, to give a root back. And so that's what we're going to do. We're going to reduce this. This is going to be 1/6. And we're going to bring this to the front. This is the square root of 2x plus 3 to the 3rd power minus, this is going to be 3/2 square root of 2x plus 3. And that looks like the right answer to me. And I wrote this 2 out here so you can see what was going on with it and what we did with it. And obviously there would be a 1 right here. And so that's what a square root means. So the final answer we can write as 2x plus 3 quantity cubed all over 6 minus 3 times the square root of 2x plus 3 all over 2 plus c. And a final acceptable answer. You don't have to pretty much go any further than this. And so that's how we just use 2 different ways at the same time to show how to solve this integral using u-substitution. That should be enough to get you going for now, and if you want to see others, leave a comment in the comment section and subscribe so you never miss a notification.